In the Pacific, about 30 feet below the ocean's surface, an odd object drifts through the blue waters. This shape bears no resemblance to any fish we are familiar with. It looks as if someone started drawing a fish and left it unfinished. A massive, flat disc about 10 feet in diameter with two long fins sways slowly up and down like the wings of the world's laziest bird. This is an ocean sunfish, a molar molar. Somehow, this 2-ton biological absurdity has not yet gone extinct. Let me tell you about this creature's features. It weighs 5,000 pounds. That's as much as a large SUV. Its shell is 6 inches thick, not fat or muscle, but a protective vest made of dense collagen and elastin tissue, with the consistency and hardness of industrial rubber. Most predators in the ocean physically cannot bite through it. Its brain weighs less than 5 grams. 5 grams. In an animal that can weigh 5,000 pounds, and it has no tail. Literally no tail fin. The back half of this fish just isn't there. By every metric the internet uses to judge animals, this thing is a disaster. Slow, stupid, bizarre looking. The most roasted creature on the entire internet. Here's the part that nobody talks about, and this is the part that really keeps me up at night. This animal, this 2-ton, walnut-brained disc swimming in front of you is one of only 2 siblings to survive out of 300 million eggs. Out of 300 million. Its mother laid 300 million eggs in a single spawning event, more than any other vertebrate on Earth. That's roughly the entire population of the United States dumped into the ocean at once. And of those 300 million, 299,999,998 died, vanished. They were defeated, starved to death, crushed, dissolved, vanished. This one survived. And maybe, somewhere in the Pacific, another sibling. That's it. 2. So the question isn't, why does this animal seem so stupid? The question is, what did this animal do? Over millions of days, what biological miracles occurred one after another to turn a speck smaller than a grain of sand into a 2-ton armored giant that almost nothing in the ocean could kill? Let's go back. Let's go back to the beginning, to the moment it all started. Imagine this: open sea, no reef, no shelter, no solid ground beneath you, just endless blue in every direction and a cloud of 300 million eggs slowly drifting in the current. Each one microscopic in size, a tiny, delicate sphere made of lipids and proteins, barely visible to the naked eye. No shell, no armor, no parents to protect them. The mother is already gone. She released her eggs and left. No nest, no protection, no backward glance. In the vocabulary of evolutionary biology, this is R selection at its most extreme. Bet everything on numbers, invest nothing in individuals. And the ocean responds immediately. Within hours, the feeding begins. Planktivorous fish move through the cloud like combines through a wheat field. Filter feeders inhale thousands of eggs per minute without even trying. Currents scatter the remaining eggs across miles of open water. Some drift into temperature zones too warm or too cold for development. Some sink below the photic zone where sunlight can't reach, and the embryos inside simply stop developing. They just switch off. In the first 48 hours, roughly 2/3 of the 300 million eggs are gone. Not eaten, many just failed to develop. The ocean didn't even have to try. Of the original 300 million, approximately 100 million remain, and they haven't even hatched yet. However, this is where the first survival mechanism kicks in, and it's quite effective. When a sunfish larva finally hatches from its egg, it bears no resemblance to its parents. Absolutely none. It is round and tiny. It is encased in a transparent shell covered with spines. It resembles a medieval weapon designed by microbiologists. And this is far from coincidental. This spiny shell is a direct genetic inheritance from the sunfish's ancestors, the porcupine fish. This larval armor, which inflates its spines when threatened, was inherited millions of years ago. At this stage, the larva even has a normal tail fin. It swims like a normal fish, fast, agile, responsive. It looks like a small, spiny, completely normal juvenile fish. Nothing about its appearance suggests that one day it will become a 2-ton, tailless disc. This transformation occurs later, and it will be quite dramatic. But right now, the spiny shell is the only barrier between this sand grain-sized creature and sudden death. Most small predators cannot swallow it without sinking. It's not much, but in a 300 million year game, not much determines the line between a species' existence and extinction. Hatching from the egg? That's just the entrance exam. The real test begins now. The sunfish larva has hatched from its egg. It is alive. It is approximately 2 millimeters long, and its only task right now is to grow fast. Because in the open ocean, size is the only thing that ensures safety, and right now it is as small as pocket change. The first few weeks are like a frantic, desperate race. The larva feeds on microscopic plankton, tiny copepods, algae, anything it can find floating in the water column. Every calorie goes directly towards growth. There is no energy left for anything else. No complex behaviors, no social interaction, no exploration. Just eating, growing, surviving if possible, because death lurks around every corner and moves very quickly. The spiked shell that protected the hatchling, it's already becoming a problem. As the larva grows, the shell can't grow with it. It's rigid, fixed. The larva is literally outgrowing its own armor. Within the first couple of weeks, the spikes begin to recede. The protective shell thins out and eventually disappears entirely. This is the moment of maximum vulnerability. The old defense is gone. The new defense, the 6-inch collagen armor of the adult, won't develop for months, possibly years. The larva is now a small, soft, unprotected fish in open water, and everything eats small, soft, unprotected fish in open water. Tuna, mackerel, lancetfish, squid, even other larvae. The ocean at this scale is a continuous, omnidirectional buffet, and the sunfish larva is on the menu. Of the 100 million that hatched, approximately 5 million make it through the first month. 95% are gone. The only thing saving the survivors is speed. And I know that sounds insane given what this animal becomes, but at this stage, sunfish larvae are legitimately quick. They have that normal tail fin, remember? They can dart, they can evade, they can change direction in a fraction of a second. They move like actual fish, because at this point, they basically are actual fish. If you saw one at this stage, you would never, not in a million years, guess what it was going to become. The other thing saving them is sheer math. Pure, brutal, unfeeling statistics. 5 million is still an enormous number of individual organisms scattered across hundreds of square miles of open ocean. Even if predators are consuming them by the thousands every single hour, that's still a lot of needles in a very, very big haystack. The ocean is so vast and the larvae are so dispersed that no single predator can make a meaningful dent. It's not a strategy that works for any individual. It's a strategy that works for the species. And there's something almost beautiful about that, in a grim, mathematical sort of way. However, it is not a small, fast-growing shield that will last a lifetime. It has a disadvantage. It has an expiration date. These larvae grow a little more each day they survive, and every millimeter of growth makes them a slightly more attractive target for slightly larger predators. The period of being too small to be noticed is rapidly coming to an end. What happens next will fundamentally change everything we know about this animal. And to be honest, that's what fascinates me about this species. All right, this part really fascinates me. Bear with me, because the scientific facts here are incredible. Over the next few months, the surviving young sunfish begin one of the most extraordinary physical transformations in the world of vertebrates. And when I say unusually, I don't mean something like a caterpillar turning into a butterfly. That's at least an elegant transformation. This is more like rebuilding a car while driving it, in a junkyard, during a rainstorm. Here's what happens. The spine, the structural backbone of every fish, starts shortening. Not by a little, by a lot. Over the course of development, the sunfish reduces its vertebral count to fewer than any other ocean fish alive. Scientists believe this reduction lowers body density and saves the enormous amount of energy that would otherwise go toward growing and maintaining a heavy, calcium-rich skeleton. Less bone means less weight, means less fuel burned just existing. But here's the consequence that changes everything. The tail fin disappears. Not gradually in a cosmetic sense. The tail, the primary engine of locomotion for virtually every fish in the ocean, degenerates during development. It just goes. In its place, the dorsal and anal fins extend backward and fuse together, forming a stiff, fleshy structure called the clavus, a pseudo-tail. It generates zero active thrust. It's a bumper. The fish grows a bumper where its engine used to be. So now the juvenile sunfish has no tail, a shortened spine, and a body that's starting to flatten into the disc shape we recognize in adults. It can no longer swim like a normal fish. The old system is gone. But the new system, synchronized fin flapping, isn't fully developed yet either. This is the awkward teenage phase. Too big to hide in plankton clouds, too small for the collagen armor to protect against anything serious, too redesigned to swim properly. It's the worst of all worlds. Of the 5 million that survived the first month, roughly 10,000 make it through this transition. 10,000 out of the original 300 million. But the survivors, the 10,000 that make it through this gauntlet, are already becoming something different, something the ocean hasn't seen before in their lives. The elongated dorsal and anal fins are now functional. They begin moving in perfect synchrony. One sweeps left, the other mirrors it. It looks clumsy. It looks ridiculous, like watching a dinner plate try to fly. But hydrodynamic simulations show something remarkable. This movement pattern is extraordinarily energy efficient for a large body. It generates lift the same way a penguin's wings do underwater, but along a vertical axis instead of horizontal. The sunfish isn't becoming a worse swimmer, it's becoming a completely different kind of machine. One built not for speed, but for endurance. Not for chasing prey, but for drifting across entire ocean basins on almost no fuel. And this is where the evolutionary lineage matters. The sunfish belongs to the order Tetraodontiformes, the same group that includes pufferfish, boxfish, and triggerfish. All of them have unusual body shapes. But while its relatives evolved defensive spines or the ability to inflate like balloons, the sunfish lineage went in a completely different direction. Extreme spinal minimalism, fewer vertebrae than any other ocean fish, a flattened disc body that minimizes drag in its new locomotion style. It's like the entire species decided, we're not going to compete with sharks and tuna on their terms. We're going to invent our own game. Think about it this way. All the other big fish in the ocean are like race cars, built for speed, perfect for hunting and catching prey. On the other hand, the sunfish is like a boat powered by solar energy. It can't catch anything that can swim, but it doesn't need to. Because its prey, the creature that will spend the rest of its life with it, can't swim either. And this type of diet is probably the most absurd dietary strategy in the entire animal kingdom. The surviving young are now entering a new growth phase. They are growing rapidly, and every inch of growth makes killing them even harder. We need to talk about armor here, because this is the part that transforms the sunfish from a defenseless oddity into something nearly invincible. As the animal grows, a layer of tissue called the hypodermis begins to thicken beneath the skin. This is not fat. It's not muscle either. It's a dense matrix composed of collagen and elastin fibers, the same proteins that make tendons tough and skin elastic, woven into a structure with the consistency of heavy-duty industrial biorubber. In a fully grown animal, this layer reaches 15 centimeters in thickness. 15 centimeters! That's thicker than some bulletproof vests. The outer surface is coated in slippery mucus and has a rough, sandpaper-like texture. So even if a predator gets close enough to bite, it can't get a grip. And even if it somehow bites down, it can't penetrate 6 inches of biological rubber to reach anything vital. Sea lions have been filmed attacking sunfish, gnawing, ripping, tearing at fins and skin, and eventually just giving up, swimming away. The sunfish absorbs the beating like a punching bag that can't feel pain and keeps drifting. That's not a metaphor, that's literally what happens. But the armor does more than stop teeth. And this is the part that blew my mind. The hypodermis is composed largely of water. It has a gelatinous consistency. And here's the physics. Liquids and solids are nearly incompressible. The sunfish hunts jellyfish at depths of 650 to nearly 2,000 feet, where pressure would crush a swim bladder. But the sunfish eliminated its swim bladder entirely during development. Instead, its water-based body tissue barely changes volume regardless of depth. Zero energy spent adjusting buoyancy. It moves through the water column like a biological submarine. I'm not making this up. At this size, several hundred pounds and growing, the list of things that can kill a sunfish gets very, very short. Killer whales, large great whites, occasionally a very determined sea lion. That's essentially it. Everything else in the ocean either can't bite through the armor, can't swallow the body, or simply doesn't bother because the caloric return on attacking something this tough isn't worth the effort. The sunfish has crossed the threshold. It's gone from everything wants to eat me to almost nothing can. And the growth doesn't stop. The sunfish keeps growing for years. From that starting point of less than 0.04 ounces, a grain of sand, it must reach an average adult weight of about 4,000 pounds. That is a 60 million-fold increase in body weight. I need you to actually process that number because it's almost impossible to comprehend. It would be like a newborn human baby growing to the size of an aircraft carrier. No other vertebrate on Earth undergoes a size increase even remotely close to this. This extreme growth is the second key to survival. In the ocean, size is the most effective protection money can't buy. Every additional pound is another layer of insurance, another reason predators look the other way. Of the 10,000 that survived the transition, about 100 reached this size. 100 out of 300 million. Remember the spiny, transparent larva, the creature the size of a grain of sand with the borrowed shell of a porcupine fish? This is what it becomes, a half-ton, collagen-armored disc that most ocean predators cannot pierce. Those who survive are now adults, and their lives, which may seem boring from the outside, are actually the pinnacle of minimalist engineering. Let's talk about how this animal feeds, because it really is a unique diet. The sunfish's main food source is jellyfish, siphonophores, salps, gelatinous plankton, bags of seawater covered with a thin layer of organic matter. Jellyfish are 95% water. Eating jellyfish for nourishment is like trying to fuel a truck by burning wet newspaper. It's almost useless. But here's the brilliant thing, and I mean that word exactly. Jellyfish are everywhere, in every ocean, at every depth, in numbers beyond imagination. And no other large predator bothers to target them because the caloric yield is so low. The sunfish looked at this endless, completely unrivaled food source and said, "Yum." However, the most important thing the adult sunfish does is the culmination of this entire story. This is why we return to the beginning. Reproduction. The cycle is complete. The survivor, 1 in 300 million, releases its own 300 million eggs into the current. No protection, no care, only numbers. The system is like a giant gamble, built on the chance that at least one will complete the same impossible journey. From the initial 300 million eggs, 2 reach adulthood. 2. and each now lays another 300 million eggs. The cycle is never broken. Think about that for a second. Every adult sunfish you see in the ocean is 1 in 300 million that survived. Each one passed a test that wiped out its entire species. And now, with its walnut-sized brain, it produces the next 300 million, almost indifferent to the fact that nearly all of them will die. But the math works. It's been going for 60 million years. So what does all this actually mean? What lesson can we learn from watching a grain of sand survive with a 1 in 300 million chance and turn into a 2-ton armored disc? This means that this animal, which the internet labels as stupid, ugly, and broken, is a 60 million year old survival machine that has adapted so perfectly to its niche that no other species on Earth can compete with it. None. The 60 million years it has been unrivaled. Nothing has found a way to do what the sunfish does better than the sunfish itself. Evolution did not design this animal to be cute. It did not design it to be fast, smart, or to be a model for nature documentary posters. It evolved for survival, to persist generation after generation, era after era, in an ocean that relentlessly, mercilessly tries to kill everything within it. Every feature that looks like a design flaw is a calculated budget cut. No tail, saves skeletal energy, enables the most efficient locomotion system available for its size. A walnut-sized brain eliminates the body's single highest caloric expense. A jellyfish diet, infinite resource, zero competition, available in every ocean on Earth. 6-inch collagen skin, passive armor that works without burning a single calorie. 300 million eggs, statistical immortality that no environmental disaster can overcome. Suppress all unnecessary genes. Dedicate twice as much energy to the elements essential for survival, and what you will obtain will not be a flawed animal. It will be such a ruthlessly optimized machine for survival that it will render even our best engineering efforts obsolete. We spend billions designing submarines that can withstand pressure changes, yet the sunfish produced one from a protein like collagen. We make armor from Kevlar and ceramic plates. The sunfish, however, produces a 15-centimeter thick bio-armor beneath its skin. We use supercomputers to calculate optimal fuel efficiency. The sunfish achieved this by sacrificing its own tail. Over the past 60 million years, as many faster, smarter, more elegant fish species disappeared, the sunfish drifted on. It survived ice ages, mass extinctions, and ocean chemistry changes that destroyed entire ecosystems. It watched species come and go. It watched continents move. It watched the descendants of dinosaurs take to the skies and the first mammals venture into the sea. And it's still here, drifting, eating jellyfish, basking in the sun, thickening its armor inch by inch, not caring what anyone or anything thinks. Out of 300 million, only 2 survived, and that is enough. It has always been enough. Perhaps the brightest survival strategy is not to be the fastest, the strongest, or the smartest. Perhaps it is to be the one thing the ocean cannot eliminate, no matter how hard it tries. You just witnessed a grain of sand evolve into a 2-ton giant. If you watch this video to the end, you are more resilient than 99.99% of sunfish larvae. So subscribing should be easy for you. See you soon.